In this video, we're going to be taking a look at how we can use multiple timeframes on a given indicator in backtesting.py. So let's say you've got a series of 1 minute candles, you're calculating the RSI or the SMA or the momentum on that time frame, but you also want to use a longer time frame to confirm the trend that you think you're seeing, maybe the 10 minute or the 1 hour. How do you do that without introducing look ahead bias and really giving yourself quite the headache? Well, thankfully for us, Backtesting.py has the Resample-apply function, which we can see here in the documentation, and we'll be covering for most of this video. But the really quick summary is that basically you give it the time frame you want to resample the data to. So if I wanted to resample from 1 minute to 1 hour, I would give it the 1 hour here. You give it the function that you want to apply. So this is going to be your indicator, whatever that happens to be. You give it your time series. So this is going to be, in my case, my 1 minute open, high, low, close data. And then, of course, any arguments or keyword arguments, like the window length for the RSI or something of that nature. So we'll dive into a bit of an example here so that you can see how it works. I am going to assume a good amount of familiarity with backtesting.py. If it's completely new to you, I have a free course here on YouTube, which I'll leave a link to in the description. So basically what we've got here, we have imported our Resample-apply, which is important. It comes from backtesting.lib. And we've also imported our generic backtesting stuff, so backtest and strategy. I'm reading my data in here from a 1 minute candle CSV. If you want to follow along with the video, you can find that 1 minute CSV on data.binance.vision. You can download all of these straight from Binance as a nice zip file, and each zip file has a CSV in it. So we've got our data here. I'm just grabbing open, high, low, close, and making sure to have the date as an index rather than a column. That's quite important. So I set the index to date there. Moving on to our strategy down here. I'm only using a small subsection of the bars here. So I'm using from the 1000th bar to the 3000th bar. I'm doing that because if you try and plot too many bars, it will aggregate them and that makes life confusing. The indicator that I'm going to be using is just a simple momentum indicator here. So it takes in an array, a numpy array, and the number of bars that you want to see the difference in. So with n equals 1, it basically gives you the percentage difference since the last bar. If you do n equals 2, it gives you the percentage difference since 2 bars ago. And this is an attempt to basically measure the momentum or trend that the price is currently in. I'm using this rather than something like pandas TA because it demonstrates that you can use any sort of indicator you like with this, and Resample-apply will work just fine. Moving on, we have a class called RSI oscillator because I forgot to rename it, and all of our class parameters here. And so if we move on down to init, this is where you're going to be actually calculating your indicators, and it's also where you're going to be doing most of your resampling. The reason for that being that init is only called once at the beginning, and if we can pre-compute all of those values, it's going to save us a lot of processing power. If you try and do this within next, that's going to be very, very, very slow. So we basically have two indicators here. The first one is just a standard self.i indicator. So we pass in the function, which is my momentum function that I showed you earlier. We pass in the data, and I pass in the value for n, which in my case is going to be 2 because that's what I've got it saved as here in the class variable. So that's straightforward enough. This short momentum here will get me the percentage difference in price for the last 2 bars on a rolling basis. And it's going to use self.data.close, and the time frame that I'm feeding into this is going to be the 1 minute. So it's going to get me the 1 minute percentage change for the last 2 bars. Now, being 1 minute candles, this is going to look kind of crazy, so we might want to look at this on a longer time frame here. So I've got self.longMomentum is equal to resample-apply, and then you give it the time frame that you want to resample it to. So I'm going to give it 10t. The t here stands for minute. It doesn't use m because m stands for month. If you want to look at more different kinds of date formats here, you can check the pandas documentation. That's where these are pulled from, because underneath the surface, Backtesting.py is just using pandas to do this for us. So if you go to the pandas docs, you go to the user guide, and you go down to time series/date functionality, and then date offset objects. So it's buried quite deep here. Scroll down a bit, and you'll see all of these different date offsets here. So for example, week is W, as you might expect. Month end is capital M. There's also things like quarter here. So if you wanted some really long-term aggregation, you could use quarter. Various other date time offsets here to get exactly the kind of results that you're after. But for us, we really care about the minute one here, so that's T or min, which is what we're using. I just thought I'd point to this page in the documentation because that can be quite difficult to find if you've never looked it up before. And then, other than providing the new time frame, there's not much that changes from the regular self.i. We still provide the same function that we want to apply, so I could apply the momentum function, or I could apply a different function if I wanted to. I could grab one from TA, so I could do ta.rsi or something like that. I'll give an example of that later on. We provide the same data source that we used previously. So I'm using the closing values here. I'm then feeding in any parameters that I have to my function. And then finally, I've got plot equals false here. So what that does, as you might expect, is it stops this indicator from being plotted. So if I run things here, you can see that it's plotting the first momentum indicator here. So this is the 1 minute. You can see by how crazy and volatile it is. But it's not plotting the resample-apply one here. It's not plotting our long momentum function. If I want to include that on the final backtest there, very simple. All you have to do is that. And now you can see our momentum here, which is obviously much more square because it's using longer term timeframes. So I hope that's making sense here. If we wanted to, we could add another momentum indicator down here. We could say that we want a longer momentum, and this is going to be 1 hour. And exactly the same thing is just going to apply here. Super, super simple. And you can see it down in the bottom. Again, much less granular as you would expect. And it helpfully generates these little labels here. So you can see that this is the 10t, this is the 1 hour. So you can differentiate between them on your final backtest here. It's definitely worth reading the documentation for this function if it's something you're going to be using regularly. You can scroll down a bit here and you'll get basically the gist of what it's actually doing underneath the surface. It's converting your data back to a pandas series and then using the regular old pandas series.resample function in order to actually do the resampling and then build a regular self.i indicator using this resampled data. Now, the reason why you might want to use this function rather than doing everything that I just said manually is that the author of the library has thought relatively hard about it and included some sensible defaults here, like, for example, this label parameter, which you might not think of, but if you don't, then you're going to introduce some look-ahead bias, which is going to be a real problem when you start to go live. Obviously, this only works if the time frame you're resampling to is larger than the time frame that you're resampling from. So try and feed in the smallest time frame that you can get, so 1 minute data or even 1 second data, and that way you can easily resample up to 1 hour, 1 day, 1 year, etc., etc. Just to show another example here, I'll include a pandas TA function. So instead of using my momentum function, which I built up here, using regular old NumPy code basically, if you wanted to use something from a library, very, very simple. So I just imported pandas TA up here at the top. And then if we go down here, all you have to do is replace the name of the function here. So instead of momentum, it's going to be ta.rsi. Same thing down here, ta.rsi. And pandas TA takes in a pandas series, as you might imagine. So instead of self.data.close, we do self.data.close.s. Now this .s on the end here allows you to retrieve the data as a pandas series rather than a numpy array. Obviously this self.momentum bars doesn't really make sense anymore, as this is now going to be the RSI window, so I could put 21 in there. That would be a sensible RSI window. And let's run that. So that looks good to me. That looks something like what an RSI should look like. It's giving reasonable values. And again, you can see that the labels here are giving very helpful prompts. So we can see that I forgot to change this one up here. So I can change this one to ta.rsi, self.data.close.s, and then provide a sensible window value, so say 21, and that should work just fine. As I mentioned before, this syntax works perfectly well with keyword arguments as well. So if I open up another terminal here, we could have a look at another indicator and see how we would implement that, just to give you another example here. So I'll import pandas TA as TA. We could then look at the awesome oscillator here. So if I do help rsi.ao, or rather help ta.ao, you can see that this one uses the high and the low. So it's taking in two different inputs here. And you can also provide things like the fast and the slow value. So very, very simple to do that. It's the same sort of thing we've been doing. All you do, go to the relevant function. So I'm just going to change this short momentum here. It's going to be using the awesome oscillator. So ta.ao. And then you can just provide the high and the low, either as positional or keyword arguments. I'm just going to make it keyword here, just so that it's very obvious what's happening. So this is going to be the high, then the low I'll just put down here. .s, and then we can also provide a keyword argument. So for example, I could change the default fast value here to be 10, for example. And that should work just fine. Yeah, so you can see that took in multiple different pandas series there, and it worked just fine. So I think with those two examples, you should be equipped to do this with pretty much any kind of indicator you can think of, one that you might think up yourself, or one coming from another library. Whether it uses numpy arrays or pandas series, you should be good to go. And you also now know all of the different time formats that you can put into Resample-apply here to get your indicators working on different time frames. So you should be good to go. I hope you enjoyed the video, and I'll see you in the next one.